So today we're going to be learning about Newton's method and how it can be used to approximate the zeros of a function. So given the function f of x equals x cubed minus x plus 4, we're going to find this zero as shown on the graph. The equation for Newton's method is x sub n plus 1 equals x sub n minus f of x sub n over f prime of x sub n. So first off, if we take a look at this graph, we find that f of -1, so -1 is right here, and f of -1 equals 4, which is greater than 0. And then if we look at f of -2, we find that f of -2 equals -2, which is less than 0. And we know that f is continuous. So then using the intermediate value theorem, we know that f must have a 0 on the interval from -2 to -1. Because the 0 appears closer to x equals -2, right here, we choose x sub 0 equals -2 as our initial guess. We also need to know that f prime of x equals 3x squared minus 1. And that can be found just using the power rule on our original function. So if Newton's method gives us x sub n plus 1 equals x sub n minus f of x sub n over f prime of x sub n, we can then plug our function into this formula. So we get x sub n minus x sub n cubed minus x sub n plus 4 over 3 x sub n squared minus 1. And for this, n is going to equal 0, 1, 2, and so on and so forth. So using x sub 0 equals -2, we get x sub 1, because you have x sub n plus 1 in your formula, equals -2 minus -2 cubed minus -2 plus 4 over 3 times -2 squared minus 1, which that equals -2 minus -8 plus 2 plus 4 over 12 minus 1, which equals -2 minus -2 over 11, which this just turns into plus 2 over 11, and then that equals -20 over 11. So then using x sub 1 equals -20 over 11, we're going to go to another page. So then if we say x sub 1 equals -20 over 11, we can then plug that in. So then x sub 2 equals -20 over 11 minus -20 over 11 cubed minus -20 over 11 plus 4 over 3, that's a 3, times -20 over 11 squared minus 1. So then if we just plug this into our calculator, So we plugged it in up here. We get x sub 2 equals negative 1.7966133026. So if you can see here, we just took our answer from this equation down here, x sub 0 equals negative 2, and then we got and then we found x sub 1 by plugging in negative 2, which gave us negative 20 over 11. So then we took negative 20 over 11 as our answer from x sub 1 and plugged this in to find x sub 2, which gives us negative 1.7966133026. So basically you're just going to keep plugging in your answers from your previous equation. So to find x sub 3, we would do the same thing using this original Newton's method equation found right here. And we'll just plug this number back into that to give us x sub 3, which, because it's an incredibly long equation, we just plugged it into our calculator. And from that we got negative 1.796321.956. And then to find x sub 4, we're going to do the same thing and just plug this back into the equation. So then for x sub 4, we got about negative 1.796321.903. And then we're just going to do this again to get x sub 5, which gives us about negative 1.796321.903. And as you can see, our x sub 5 is equal to our x sub 4. So at this point we can stop because we can't find any closer of an approximation. So just to last double check our answer, we're going to plug in f of x sub 5. So we're just going to find this. And we just did this on our calculator. So this last calculation at the bottom, which gives us, and this is plugging it back into our original function. So the original function is x cubed minus x plus 4. So this is plugging negative 1.796321.903 back into that original function to check our answer. So that gives us 2.2521 times 10 to the negative 9, which is about 0. So we're just going to say it's about 2 times 10 to the negative 9, and that's about 0. So then we can say that our answer, the approximate 0 that we're calculating on this original graph right here, the approximate 0 of that is about 1.796321.903, also known as our answer for x sub 5.